Okay, so this is the introduction to lists. Lists are also sequences. And so I'm going to run through three very similar examples for lists to be compared with the examples we did previously for strings. That's what's showing here. Um, so for the lists, let me run this first function here and then quickly discuss it. So list one under bar one defines three lists as you see. L1, which has 6 elements. L2, which has 6 elements. And L3, which has 6 elements. So they all have the same length in this case. One of the nice features of lists is you can mix data types. So I have an int and a string and a float in this first one, and in fact in the other ones as well. And so when you look through these print statements, the first one I'm checking the Boolean equality of a list with itself. That's true. The Boolean equality of L1 with L2, that's false. When you compare element by element, for two lists to be true, element 1 has to be equal to element 1 here. Element 2 here has to be element 2 there. And that's the rub here. Um, dogs with a small d is not equal to dogs with a big D. All the other ones, all the other corresponding elements are equal, but not that one, and so you get a false for the output. L1, is it Boolean equal to L3 or not? And that comes out with a false. Well, why is that true? The reason is because L1 and L3 differ in order. So the order matters in a list. And then L2 equals L3 um, is going to be both the fact that the order is different and that dogs with a big D is not equal to dogs with a little d. So let me run the second function. List one under bar 2 would be that. And so here I'm using the length function. Works just like it does in for strings. And so the first thing I do is I compute the length of L1, L2, L3. I didn't compute the length of L4 here. But in any event, L1, L2, and L3 are all 6 long. And then if you look at L4, you can see L4 has 1, 2, 3, 4, 5, 6, and it has a 7th element, which is a space. It's a string space here, and so that counts as an element. So the next thing, three print statements I do is I compute the relative length of L1 and L2 and whether L1 is longer than L2 or not. And that the Boolean statement of that is len of L1 is bigger than len of L2. That's a false statement. They both have length 6, so 6 is not bigger than 6. The second one, L1 is at least as long as L2 would translate to len of L1 is larger than or equal to L2, while 6 is bigger than or equal to 6, and so that's a true statement. This next one down, L1 is longer than L3. Well, that's false because len of L1 is 6 and len of L3 is 6. And lastly, we have L4 is longer than L1. I meant to say longer than. There's a typo there. In fact, let's fix that right now. Longer than. Let me go ahead and save that. And then rerun it. That's a true statement. len of L4 is 7. Len of L1 is 6. So 7 is indeed larger than 6. Okay, last one, the underbar 3, 1. Run it. So what I'm doing there is I'm defining 3 lists, and what I'm going to do is I'm going to traverse the list just in an exactly analogous way that I traversed the strings in the previous example. And so what I'm going to do here is I'm going to say characters in L1. So that's this preliminary statement before the traversal. 1 comma dogs, comma 2 comma cats, comma 3.2 comma meters. I do have a comma on the end, the way I've written this. And so I'm traversing L1. This naked print statement forces the print output to go to the next line, and so then I do the same thing with L2, and I do the same thing with L3. And so there's a lot of similarities between um, strings and lists. They're both sequences, so order matters, number matters, um, and so what we'll be looking at in addition in this chapter is indexing. Any sequence can be indexed, so that's the next YouTube. Talk about indexing in strings and in lists, and then they also have methods. And so you're already familiar with one string method, list method, I should say, dot append.